So this is kind of to demonstrate lead. So this is a standard single lead thread. I put a black mark on the top of this washer and a piece of tape down here so you can see where it starts. Now I'll do one 360-degree turn and you'll see how far it travels. And that will be your lead. So let me unscrew it one time. So I'll just take this and take it and turn it till I get to the black mark again on the top. Now notice that you now have one thread that you see. Right? That's a single lead thread. So again, the slope of the tooth determines that. Now let's look at this one. This is a double thread. Oh, you can't see that. Holy smokes. Let me get a little further away here. Am I going in or out?
You're going out.
Neither do I. Focus it. Okay, so this one, and I don't know if you can compare it, but you can kind of see maybe that the slope of the tooth, it's kind of hard to see. If you put them next to each other, you'll be able to see it. The slope is significantly different. Now here, if you look on the bottom here, I've got a black mark on both of these threads. Now I'm going to turn it one 360-degree turn. So I'll bring the black mark to the top. So you can kind of see it right there again.
So is that 2?
This is the original one. It's kind of hard to see where my finger is.
Mm-hmm.
Notice there's 2 threads that you see there. Okay, but it's a double thread. In essence, you can tighten it on and off twice as fast. Now, why do they use these leads? Well, it depends on the kind of torque and stuff you're putting on them. A single lead actually has more mating surface inside the washer, so it's a little stronger. Okay. Double threads, you get a little bit less, right? Because whenever you just think of something, if I'm pushing on something, and that's what a thread is, right? These are pulling or pushing. Okay. So if I'm pushing against this, do I get a big stop, a vertical surface? Okay. Yeah, I do, right? What happens is I start to bend that. What can happen now, it starts to deflect, right? I'm not getting full force. The more you tilt it, you know, it's starting to bend and stuff, the forces are going out. So the single threads are stronger, but maybe it's strong enough as it is, and we don't need that extra strength, and we'd rather have speed of bringing them on. Yes?
Okay, so this is probably stupid, we should stop the recorder. But, so you know when you strip a screw,
Yes?
is it because it's sloped so much?
No?
Oh no, so why?
Well,
Just too
now,
much
are you
pressure?
talking an external fastener and you screw it in, and usually when you strip it, what's going on there is that you are matching the 2 wrong devices up. So like you might be saying, oh, I've got a diameter 3/4, 8 threads per inch washer, and I'm trying to turn that onto a diameter 3/4 inch dash 20 threads per inch, right? The threads aren't machined to work with each other. And so you strip it.
So you're saying like if you had wood and it's softer, then it's the internal part is getting, the teeth are going away.
Well, wood's kind of a bad pick because we really only have, we got cutting threads like on a wood screw and a lag screw, and they cut their own threads as they go into a wood thing, right? You want to think more metal. And as an example, you know, I've got, and you can see that quite easily, like that one I've got up here. I've got other diameter threads on here that are the same. Try and set them on. You get about 1/4 to maybe a full turn and they'll start to bind. You're screwing up at that point. Got 2 things that aren't built to mate. That's generally it. I'm not sure if that's what you need. I do have one other thing before we move to the drawing stage. I would like you, because I don't have them here, jump on YouTube and watch a video on tapping a hole and dyeing a shaft. And it's spelled this way. Okay. It's how you make threads. This might open up a big So what you're looking for here is tap and die, and it's D-I-E. And just watch a quick YouTube or something on how to tap a hole, which is this is how we make an internal cylinder right here, tap. Okay, we drill into a piece of metal and then we cut the threads. The die is how you do an external fastener. It looks like a nut, but you turn it onto a shaft and it cuts the threads. Okay. So watch a video on those. And I'm sure you can find them for 5 minutes each. We're talking 10 minutes of your time. And you can understand how threads are made. All right, turn to page 920, please.
Is that how all threads are made, tap and die?
Yeah, as far as I know. I don't think we can cast them. Maybe we can. But I know tap and die is far and away the big part. Now these big mass tool fastener companies like Fastenal, I don't know, maybe they figured out how to cast them. I don't know. Do you see the examples on the bottom page 920 on how to draw a simplified thread? These are good examples. Here's the thread we're going to draw. Okay, 1 inch. It's going to be a -8 UNC, -2A. So again, major diameter, threads per inch, thread form, Unified National, thread tolerancing, it's a coarse thread. Class of fit is 2, A is external, B is internal. Okay. Now, to do this, to draw on the simplified, you must need to know the minor and major diameters. You will approximate them. How are we going to get the minor diameter on this stuff?
The line? Oh, you get the pitch and then go back.
No, it's documented somewhere.
Yeah,
Yeah,
that was gonna
Machiner's
say.
Handbook. So you would dive into that reference book. Now, before you go grab one, open the internet browser if you would. And type in theoretical machinist. And don't ask me how to spell either one of those, it's way beyond my capability. But I got it close enough, it found me a website called theoreticalmachinist.com. Click into that website. I have got this spot bookmarked specifically for these lectures because I don't have a machiner's handbook in my room. Is everybody on this page right here? I'm going to wait until we're all here. Okay. Thread calculator. Right here. Your bolts. You want to put any of this stuff on your phone? Okay, you can get it. The other tap drills. How do we make externals? A lot of other things in here. There's even a unit conversion for you if you need it. Click into the second one there, UN thread calculator. Right there on the top left, thread builder, choose your thread. (1-8 UNC). Now you then come down and make sure it's already plugged some of it in. It assumes a class fit of 2, which is probably 90% of the threads. So just, but this where you can change some of that stuff. Hit compute. And it should fill out the right side of the screen. Now I also kind of like this website because it's got these diagrams on it. Where do you think these came from? They're identical to your text, right? So here's all your definitions of everything you need. It's all right here. Nice handy reference that you can have right on your phone. I'm going to go back up a little bit. So now, keep in mind, as it comes through, we're using this to draw. We're not a machinist. We're going to do an approximate size. So if I'm doing a -1-8, comes over here, major diameter is this. 99.80, right? Because an external thread fastener has to fit inside a nut. It's not 1 inch, but you're going to draw the major diameter of 1 inch. Doesn't matter. That major is always whatever that is. Now the minor diameter is given right here. It's really 0.849 to 8206. Okay? So just pick a number in here. You're gonna, it's a tolerance, right? They've given you the limits. They use something that's easy. Okay? I would use 0.84 because I need half of that, and it's pretty easy for me to do that number in my head. That'd be 0.41, right? You might want to bookmark this site. You'll need it a lot over the next week and a half or 2. All right, now let's draw an external. I'm going to follow the example on page 920. So let's go to CAD. I'm going to draw on the 0 layer so you can see it better, but you'll want to use appropriate. First thing you're going to do is just draw a horizontal line. I don't care how long. This is your center line. We generally do these off the center. Okay, first thing we want to do, offset for our major diameter. Which would be what?
1.
But if you're also
So
gonna
what's
make
the value I'm
0.5,
going to use here? 1, do you know? I've got a diameter of 1, but I just drew my center line. So I'm going to offset half of 1, right? If that's the center of my fastener, okay, you're drawing this view right here, just like they got in the text. I just drew my center line down the center. I'm going to offset half my diameter to get my major diameter, right? That's 0.5. Okay, you should be looking something like this now, where I have 3 lines. If you want to, change your center line to a red one, so it looks like a center line, so you remember. Now we're going to offset. Let me not go too fast here. Everybody here? This is already written in your text for you. I'm doing exactly what's in the text. Now I'm going to offset for the minor diameter. My minor diameter is 0.84, right? So we're going to offset what? Becca, you know?
what?
I'm offsetting for my minor diameter. So my major offset was equal to 1 divided by 2, which is equal to 0.5. My minor is equal to 0.84 divided by 2, which is equal to
0.42.
I want to add a little decimal there. Your minor diameter with the simplified version is a hidden line. I'm doing the simplified version, right? Let's close off the end. When you draw the chamfer, if you have to draw the chamfer, you're going to start it on your root or minor diameter, and it runs at 45 degrees. Okay? So if you want to just watch me for a second, then I'll let you do it. So I'm just going to do a line from here, and you can use polar. I like to leave my polar at 90, and I'm just going to lock this in at minus 45 degrees. There it is. I'll mirror it. Oops, didn't want that second line. I'm going to take that, mirror it to the other side, and then trim up. So that's that. And it's going to look like this. Everybody there? Who needs more time?
I just need to try. Never mind, I can mirror that again.
Huh?
Nothing.
Are you there now, Missy?
I'm there.
Okay, now I'm going to draw my chamfer line, because remember, this is a round, there's a plane change right there. So I need to include this one line right here for the end of my chamfer.
And you said that's a light line?
Yeah, I would make it a 012 line. It's not a real prominent edge, right? That's it. Easy, easy peasy, right?
Mm-hmm.
All right, now what if we're doing a cap screw or something? There are a bunch of formulas that allow you to finish those off. I would reference you to page 928. On there, there's one drawing a hex head bolt. You see that on page 928? Look on to page 929 down step 5. See down there in italicized, thread length is equal 2 times the diameter plus 1/4 inch.
Mm-hmm.
So what does that mean?
So that's the formula for how far the.
Yeah, so for us, we're a 1 inch. 2 times it's 2,
Mm-hmm.
plus 1/4 inch is 2.25. So I'm going to do an offset of 2.25. Throw it out. And I'll just extend that up, and I'm trimming my interior or root diameter back to it. So you're going to end up with this. Now, if it's a machine screw, it's just threaded all the way to the head. Does that look just like the drawing on page 920? Yes, Kate?
What's the purpose of those screws? Like, why would they be turned on that?
Clamp them. Because if I'm passing this shaft through an internal part and I'm putting pressure on it, those threads are going to get all dinged up and not work, right? So that's what the shaft is for, is to pass through parts, and we're not gonna rip our threads up. I mean, your houses all have these on. This is an anchor bolt, right? That's sitting in the top of the concrete. You drew those in your foundation. Those are all these. Because it's passing through concrete, passing through a board, and then we're clamping on top with a nut and a washer. Another thing that might help you with that, Gabe, there's an example on joining. Back in the joining part, let me kind of point you to that figure and see if that makes sense. Gotta find the page here. Where the heck is it? I'll find it. Thought I was at the very start of the chapter, but maybe it's later on. Oh, page 926, 927. Look on those pages, you're gonna see bunches of examples and why those are there. You see, like on 926, the shaft passes through those parts. Because we're gonna rip those threads up, moving them in and out.
Yeah.
By the way, there's no reason to spend the money to thread it.
But wouldn't it be stronger if it was threaded all the way?
No, because the only thing that's holding it's that nut. You only have to add the thread where the nut's gonna use.
They get that distance from the formula,
Yes?
or that length.
That is correct.
The 2 times diameter plus a quarter.
Yep. All right, so we just drew the external. Now, I'm not gonna go over drawing the bolt head, but it's on page 928. The bolt head is actually built off of the formula off the major diameter tube. It's all formula driven. Okay, so you'll see in there when you're drawing the bolt head, it's about a circumscribed hexagon around a circle that's equal to, I think, 3/4 times your diameter, something. Right? There's a formula on that also. I'll let you figure that one out because you're going to get it as an assignment. All right, should we do an internal? All right, first thing, if you're going to draw an internal, you need something to put it in. So if you would just draw a rectangle, that's going to be your little box or a piece of steel. So just draw a rectangle. We're going to locate where it occurs, right? Because we're going to draw the center line again. So this is an internal thread. So I'm just going to come in here and say, you know what, I've got, I'm going to use my midpoint stamp. It's going to be right in the center. Now, one thing they don't show you on this is a blind hole. So we're going to do a blind hole. The example for this is on page 922, simplified internal thread for a blind hole. If you turn to page 924, see on the top right there, figure 1920? Blind hole is a hole that doesn't pass completely through an object, right? Okay. Now, when we talk about a blind hole, let me just I'll put this up. Okay, so I've got a different thread note on this. It's now a B, right? And if it's a blind hole, then we've got to do depth, right? So we'd say depth, how about, it's a 1 incher, right? This can be pretty big. And I wouldn't use a cap screw on a blind hole, by the way. Depth, let's just go, how about, I don't know, 2.50. Okay. So we'll do a 2.5 inch depth on this blind hole. Now, when I call out the depth, 2.5, and I'm looking at this, here's my blind hole representation. Where does the 2.5 go to? It goes to whatever is usable of the hole. Okay. So the drill bit on the end is not usable. So that dimension, that 2.5, is that dimension right there. Okay. You draw the tip of the tap at the bottom. And in fact, this one just shows a drill bit. If you have a tapped hole, you add another 1/4 inch to that, and there's an example in the text on that too. All right, so let's do a blind hole. Okay, so we just drew our center line. We're doing the same thread. So what's my offset distance?
25.
Yes, it is. So it's half my major. So an offset of 0.5. Now, is it really 0.5? No, we're approximating it. Now, what's my minor diameter? Well, I'm going to bring my calculator back out because this is going to change. Because when we looked at the 1-8 UNC, we used a 2A, didn't we?